And we're back. And this is sadly the last session for Rust in Arts. It's been an amazing day, but it's not over quite yet. I'm very happy that I can bring this little conference in a full circle to a full circle moment. In the first talk today, we had doing generative art with a Rust framework called Nannou, and for the last session, we will have basically the minds behind Nannou, a studio called MindBuffer, based in Australia. And they created this framework and they do amazing things with it. And we're going to learn a little bit about how they do their work, how Nannou was created. And please give it up for Mitch and Josh from MindBuffer and an exploration of Nannou.
Well, welcome Rustfest to Rustfest 2021. This will be our little presentation on MindBuffer and how we use Nannou. So
yeah, good to see everyone, and we're very excited because Rust is something that's very near and dear to our hearts, and especially the creative side and creative applications of it. So I'm excited to be here today to talk to everybody. So maybe we'll talk about just what we'll present in our short time. Mm-hmm. Just a little bit about who we are and the kind of work that we've been doing with Rust and with Nannou, which we'll talk a bit more about later. How I've used it for projects over the last couple of years, and how we can get you guys involved in Nannou going forward. So maybe just to quickly demonstrate what it is that we've done with this, I'll just show a little teaser which outlines some snippets.
Yeah. Yeah, so there's a lot going on there, but hopefully gives you an idea of the kind of work that we're doing. We love to play with anything that we can plug into, like lasers or projections, audio. However, originally, both Josh and I started out as musicians. This little slide gives an idea of our history and how we got to where we are.
Yeah.
So I started with violin, Josh started with trumpet. We moved on to eventually found electronic music and got into wanting to make it ourselves. And then getting into electronic music ended up leading us towards wanting to make our own tools, and just so that we could better sort of exploit computers to do things that you can't do otherwise, because that's the fun of computers, right? So that got us into sort of experimenting with Macs and that sort of thing. But then it turns out that if you want to play around with audio just happens to be one of the most performance demanding sort of domains that you can get into for software. So that led us down the rabbit hole of getting into C++ and experimenting with open frameworks. I think working with C++ sort of left a lot to be desired in terms of how we structured our work, and because we're also both self-taught programmers, so you can just imagine what our early C++ code bases probably look like. Eventually we sort of stumbled upon Rust, and it turns out that Rust just won't even let you compile your program unless you've cleared all of these certain safety guarantees. You know that if you do compile it, then there's at least a whole class of problems that can't happen. And so that was extremely appealing, because it sort of let us think about the artwork more so than the code, because the code and getting past compiler errors is just a thing that you can kind of do without thinking too much about it, but you can keep the actual artwork in your mind, not having to worry about, do I have to worry about my memory management here, or is this going to seg fault or whatever. It
also gave us a lot of confidence that when we did launch a project, that going through all the compiler errors while we're making the project would give us a bit of confidence that it would run after we launched.
Exactly.
We launched 3 projects, which we'll talk about later, that are running for the next 15 years. And we haven't heard from them since they launched 3 years ago, and they're still running. And thanks to Rust for that. I just don't think that our open frameworks applications would have done that, and not just, probably says more for our coding ability at the time, but Rust has really been a bit of a lifesaver for us and gives us the confidence to do this sort of stuff.
And that's another thing as well. It's like, having used Rust now for the past few years and like built so much stuff with it, we could probably go back to something like open frameworks now. And now that we have more of an understanding on why these things are the way they are, we would just sort of naturally code with a better practice. But that's also something that you just, I don't know, it's much easier to learn with Rust than through trying to solve segfaults for weeks at a time.
Exactly.
Yeah.
So I guess one of the interesting things that we found ourselves in, as Mitch said, we're not computer science students as our background. We come from it from a musical point of view, and we bumped into this just wanting to express ourselves in ways that existing tools wouldn't let us. So it turns out that there's this whole subfield of creative coding, which probably isn't as niche anymore as it was when we got into it. But you have lots of tools out there like P5.js and processing and open frameworks and even Touch Designer, I guess you could call creative coding, that allow a lot of people to get into this field now, and kind of like blurs the boundary between the domain you're maybe coming from and a domain you haven't worked in before. So for example, you might be used to working as a musician and having a sonic output, but suddenly you can start putting things like depth cameras in, or sensors, and then getting the data from that, and instead of having a keyboard input, you're sonifying the result of like you dancing around or anything. So
totally. I think that was one of the big revelations for us getting into it. Like, being both musicians, beforehand our inputs were sort of just like our compositional ideas, and the outputs were between 20 hertz and 20 kilohertz. But like, once we got into programming and we realized like how easy it is to plug into everything and how you can represent everything with numbers basically and that information, it became not just playing from 20 hertz to 20 kilohertz, but just all of information. And so now we kind of see our work as just what kind of inputs can we experiment with, and like what kind of toys that we have to plug into as outputs. And we're just down to work with anything really, whether it's like custom stuff or commercial hardware, whatever. It's like, it's more about just experimenting. And
I think we've also found like a lot of richness in like taking data and going to multiple outputs simultaneously. Having functions that not just go to an audio output or a visual output, but like massaging this one output to go to multiple different domains.
Totally. It's like sort of abstracting the pattern generation and the composition away from the actual specific outputs or the inputs, and thinking about how we can write it in a way where whatever it is that you're playing with, you can sort of sit down for a couple of days and throw something awesome together, and based on work that you've already done. And so
that's been very
forever getting closer to that goal.
It's never ending.
Exactly.
I guess that kind of brings us to Nannou, which some people may be familiar with. We did actually run a workshop at a Rust Fest in 2019 in Barcelona, which was a lot of fun. Had a very packed room, and it was very inspiring for us to meet a lot of fellow people interested in this framework. Actually,
we should show it. I've got a good picture, Josh. I'll send that to you.
Okay, cool. Put it up, and obviously it was inspired by our previous attempts at doing creative coding, but we did really feel like Rust, with all of its benefits, could be something really interesting for the creative coding community as well. And so we really wanted to kind of stand on the shoulders of giants in that sense of being inspired by what has come before us, but really leveraging the Rust programming framework and making it open source for going forward.
Yeah, exactly. Having used open frameworks for a long time and then coming across Rust, there was just this obvious like big world of potential here. Like, creative coding tends to be quite demanding on like performance-wise, especially when you leave sort of the domain of doing sort of sketches and you want to get into real-time audio, or maybe you do some custom electronic stuff or whatever. Then if C++ is the only option, then it was obvious that Rust had such great potential for something along the lines of like open frameworks of processing. So there was many years of getting all the necessary libraries together and building up a sort of foundation. And now, as you can see, we've got a few. This is just sort of like the surface
selection
of the kinds of stuff that we've been working on to get Nannou going. But
But I mean, a lot of this stuff can also be abstracted away and used with other frameworks or with other projects, and really trying to build all this technology in a modular way, so they can be leveraged by a larger portion of the Rust ecosystem. So maybe just an example of just some of the syntax of how easy it is to get started. It really tries to be a batteries included framework where everything is just as easily accessible as possible, so that the creativity is kind of put to the forefront. So for example, if you just want to draw a bunch of circles onto a canvas, then you've got a builder chain, a builder method that we use here for specifying all of this, and it's kind of as easy as this.
This was like a really important reason why even Josh and I could get into this, was because people behind works like processing and open frameworks were really thinking about, all right, our target audience isn't a bunch of computer scientists who want to make nice things, it's artists who want to work with computers to make things that they couldn't do otherwise, or make computers do things that people maybe think they shouldn't be able to do. And so approachability is like a really big thing for us as well, trying to keep the canvas as simple and clean as possible, so that when you do feel like creating, you can just sort of get right in there and get sketching really quickly.
So I mean, obviously graphics and audio is just one side of it, but there's like actually many domains that at least us as MindBuffer are very interested in, working with laser projectors and lighting fixtures using ArtNet and DMX, all the way to different communication protocols for sending open sound control or working with external hardware. So we really try to have a way of targeting all of these different outputs within Nannou itself. I guess probably that has been inspired by just what we see as a bit, I mean, I guess I'll show this slide here. We originally started out when we started as musicians, wanting to add a visual element to our show, and it was just getting a little bit crazy that we had separate software for each different stage that we wanted to play with, and in the end you just have to start writing these huge kind of networks of interchangeable software elements, which gets confusing very quickly if you're
especially when you're in front of an audience and you're about to play for an hour and you've got like so many different pieces of software open. And I remember for this particular gig, Josh was compiling processing sketches while we were playing live, and then like I don't even know what you're doing to crossfade between the windows.
Anyways, I mean, there's something to be said about live coding, and that's all well and good. But
but live processing compilation, I don't know.
I don't know. So, and then if we wanted to start working with other types of software like lasers, then obviously like there's Pangolin's the industry standard for this sort of stuff, but then it requires you to have a Pangolin license, and then same with like projection mapping is MadMapper, and I'm sure there's other software out there, but it definitely seemed like there was all of these domains had their own siloed bits of software that required you to have n number of licenses if you wanted to work with other things. And I guess this was kind of we wanted to work with all of these things, and we were too poor to afford all these licenses and didn't feel like it would give us much benefit even if we had the money to do so. So
we're also just so used to working in the music domain as well, where it's like
much more open.
I don't know, it's much more open generally, I guess. And but for lots of these stranger pieces of hardware, it's crazy the hoops that you've got to jump through just to send some sweet patterns. And then once you do buy all the software, then you've got to hope that your vision fits into whatever their 20-year-old piece of software actually lets you do. So
So hence the reason why we developed Nannou and have open sourced it, and allow access to all these tools behind the scenes. And so really wanting to liberate artists to work with all these domains, and not feel like they have to be siloed into one or the other. But definitely standing on the shoulders of giants with all of this, so we want to acknowledge that, but I guess it's a big team effort. If we all work together, we can democratize this space and do cool stuff.
That's the joy. It's like all of these kinds of things, like these fancy pieces of hardware and protocols and stuff. The beauty about doing it open source is that we can all collaborate on it together and solve each of those things one time. And then we can all sort of like benefit from it. And like the stuff that really matters is the stuff that we make on top. But you can kind of see Nannou as like this big sort of shared, we see it as like a shared foundation where we can work with the community and build a bunch of tools that are, I don't know, things that you don't want to have to build twice.
Exactly.
And so that you can, go nuts. create what you want.
Yeah, so I guess that gives a bit of a background of the motivations behind Nannou. Maybe now's a good time to just show some projects that Mitch and I have previously done with Nannou, and talk a little bit behind how they were used, just so you can get an idea of what it looks like out in the wild. So this first one was actually called Lattice, that we did for a museum called ScienceWorks in Melbourne, Victoria, where we had 300 square meters of this scrim and 5 3-watt laser projectors. And we actually wrote all of this in a month, and had the whole thing generative with a generative audio engine that Mitch will talk a bit later about, running on this, and it was going generatively for 12 months, and it was a lot of fun. But that was kind of the first project that we used lasers for to drive the development of that. So
yeah, totally. Yeah, for a lot of these projects, you'll notice that we pick the works based on what we want to actually drive forward and land in Nannou as well. So at this point, there's not a lot of hardware left actually, but it's awesome. So yeah, this one is Oracle. It's like more of a concept artwork. We almost landed it for a particular gig, but didn't work out with the venue for some reason. But yeah, lots of fun. The idea is just to move with large arrays of moving heads and sort of apply pattern generation to, I don't know, the same kind of ways that you would oscillate across like audio syncs or parameters. We wanted to have a go at sort of spatializing a large series of moving heads and see what we could do. That allowed us to get the ArtNet and DMX control all working nicely. So it's all feasible to plug into in the future. Then the next ones are some commercial works that we actually did for some museums. Maybe let Mitch talk about this. So actually the source code for this one's all online as well. So we worked with the museum and convinced them that it'd be a really nice idea if this nice public museum also had the source code publicly available for these things. So this one is a spatial audio server. So basically the idea is that you can have lots and lots of little sound sources, and you can have custom ways that they move around through the space. And then we use something called distance-based audio panning to automatically distribute the audio to the nearby speakers based on where the virtual entity is in space. And so we use Nannou basically to build a whole application to do the big 64 channel audio. 64 or 128? I don't remember.
I think it was maybe 100.
That involved lots of optimization because that had to run on the Mac Mini. And that was a mission. But like those kind of optimizations, I don't know how we would have gone about that using anything else.
Yeah.
Because lots of channels of audio, lots of sources. Some of them were real-time sources, for example, generated from other software. Some of them were actual just playing back waves and that sort of thing, and mixing it all together in real time. So yeah, it's a big project.
Definitely cool. This next one was actually for Melbourne Museum also, but they wanted us to utilize some depth cameras. So I think for this one we used the Orbeck Astra depth camera, but it's a good example of trying to plug into some hardware that only doesn't have a Rust library already. So having to create bindings so that we could get access to it and writing our own pipelines. But I think it was using the NUITrack SDK, so you could plug in multiple depth cameras in the future. So that's all there. I think this is also open source.
Yeah, I think so.
And we worked with Tom Goen on that one, which was great, and also Andy Thomas. And in the same exhibition, we also worked on with Andy Thomas to create this piece that had projection mapping and quad warping and multiple displays and custom. This is our first actually attempt at using Vulkan directly in Nannou. So this is the moment for these projects where we actually leapt from OpenGL to Vulkan. Which we've since moved to WGView.
This was a few years ago, and I think the state of the art of using Vulkan and Rust, even just Vulkan itself, was still really new. And so it was pretty hardcore. We learned a lot. A lot of this code was very low level, a lot lower level than what you would have to use today. It's much easier to do something like this in Nannou now, I think, today than it was back then. But in part, thanks to all this work, I guess.
I'll let Mitch talk about this, but we'd actually had moved to Berlin after that, and managed to keep working together on some other cool European projects. So maybe Mitch can talk about this.
We moved over to Berlin because, it was fun working in Australia and in Melbourne on these different kinds of projects. Many of the artists that inspire us the most are over in Berlin, and one of them is Hanke, and so Robert Hanke is one of the originators behind Ableton Live, and so we've kind of been following his work for a little while, and he reached out looking for someone who could do some Vulkan programming, and so we ended up collaborating with him on visualizing the output of the CBM 8032 computers, so you can kind of see them in the bottom of the picture. But basically, they don't have HDMI outputs, surprise, surprise. We worked with another programmer who read the data directly off the video card, converted into serial data, and then we were visualizing the serial data in real time with Nannou to emulate the screen, basically, so that they could do live projections and scale it up to whatever fancy resolution they wanted to do. That was a lot of fun. Worked with some really cool programmers, and it's good fun.
And then after that, the last kind of big piece that we all did with Nannou was on a project collaborating with Augmental, Nicholas Perillo, on this project called Morph, which was a large spherical robot, had 486 individual actuators with custom LED panels on the end. It was like over 80,000 programmable LEDs in total, with a 5-channel Generative sound system inside. So all of this, from like the firmware to the control software, was all 100% Rust, and it was a very, very
all
large
the control
project.
software was all Nannou, and definitely one of the bigger projects. But Nick started this. He built like a smaller prototype a few years ago, and basically we came across someone who was interested in making a really big one, so we're like, absolutely, we can do that. And so we flew Nick over to Berlin, and then all collaborated on this monstrosity for a good 6 months straight. And it's a lot of work, but it was good fun. Really interesting way of applying composition to different formats and totally custom formats. Especially like working with the spherical display. So I guess like normally you're working with rectangular displays. So we came up with basically spherical shader technique, where your coordinates are, rather than XY inputs for each pixel, they're spherical coordinates. So like the angles across different axes, plus the previous motor position, because each node is also controlled by motors, and then your output is not just one color, but a color plus your target motor position. We had fancy ways of like interpolating all that sort of stuff as well. So lots of interesting problems to solve in this one.
It was good fun. I guess it kind of goes back to what we were saying earlier, when we have like an input which might be some like a modulation signal that gets manipulated, but then we send that to not only control like the position of the external motor, but also the colors on some LEDs, and maybe a parameter affecting the granular synthesis of the audio. And so we were kind of working with these like sources that were like going out to multiple domains at the same time, which is really cool. This is just kind of give you an overview of the actual control software that we created in Nannou to control this beast. It was probably one of the bigger projects, I think, that's been created with Nannou so far.
Keep in mind we didn't have like a fancy designer for our GUI or anything. We were kind of just throwing things together while we were going along and having new ideas constantly. But I think it turned out really nice. So I
think it turned out really nicely.
Useful for what we ended up doing.
I think like a big one for us was just like how to modulate everything, coming from a musical background, and getting into how graphs work, and making sure that we could modulate the modulator and go really deep.
Exactly. When you want to be able to control everything with everything, then it's really handy to get the hang of graphs and learn how to do a topo sort and work out how that affects the order of evaluation of all your parameters and stuff like this. So,
no, we definitely learned a lot doing this project, and I think we've got a lot of interesting things that we can take with us going forward, which is great. So after totally burning out on that project, I went to Spain for a little bit and spent some time just experimenting, working on anything else basically. And so one of the things that I've always been really curious about is the idea of compiling Rust to some sort of shader language. And so basically there's a group called Embark, and
one chap in particular, Mark Klein, I think it is, or Mike Klein. He's started a project called RLSL, which is like using Rust as a shading language. And the company Embark have sort of taken it to the extremes now, and they've got a new Rust GPU project where basically they're compiling a subset of Rust to the GPU, to SPIR-V, which is the Vulkan shading language. And so I really wanted to experiment with it. And so I had a go at doing the ray tracing in one weekend thing. And it's actually unbelievable how nice it is to be able to share the same code between the GPU and the CPU. So, for example, you can describe your world and your shader language, share it between the CPU and the GPU. So on the CPU, maybe you can just cast a ray from the mouse pointer to see exactly where it is, to sample whatever the material is that you're hitting at that point, and you know that it's the exact same position as like that pixel will be colored accordingly based on the material and whatever, because the same code is actually being run in the shader itself. So I'm really excited for what that crew is doing. I think it's got big potential for changing the way that we think about working with the GPU, because in the past it's always been such a separate thing. Like you write shaders as a totally separate process, but it doesn't make sense because it often means you end up having to write the same function several times in different languages.
Multiple
just
languages.
to exactly. So keep an eye on that Rust GPU and keep it up, Embark. I want to see this happen. It's super exciting.
We're very excited about it. There's no doubt going to make its way into Nannou once it becomes a bit more mature, the ecosystem.
Yeah, absolutely. Yeah. Okay, so another project I worked on while in Spain was getting back into generative music. So generative music is really one of the things that first got me interested in programming at all. So the first projects that I did in MaxMSP and C++ were both the generative music engines, and so I sort of taken a large divergence from it for a while, like working on different kinds of projects, but I think after getting a bit burnt out on this giant big custom hardware project which involved lots of firmware, it was time for me to get back to my roots. And so it's been a lot of fun working on generative machines again and experimenting with eGUI as well. Really nice user interface library. Previously, for a lot of our past projects, we've been using Conrod, which is like a GUI library I wrote a long time ago, mostly just because there wasn't any GUI libraries at that point in time. And so, but yeah, it's been really nice to use eGUI. I think it's very similar in design, but a lot better thought out, I think. And it seems like, much more flexible. So I look forward to using it more in the future as well.
Yeah. So I guess that's kind of bringing us to the end of our talk. Just wanted to, we've been speaking a lot about how we've used Nannou for projects, but hopefully it's inspired people watching of the kinds of things that you can do, but it's by no means the only thing you can do. And so if you think that it's something of interest to you, we'd love for you to come and speak to us and hang out in our social channels, download Nannou and have a play with it, and see what you can come up with, because we really want to foster this sense of a creative community behind this. And we fully believe that we're all can share creative ideas to help one another. So
and if you've got any questions or you've made something with Nannou, please come and see us on the Matrix channels and share your creations or share your questions. There's no stupid questions. Everyone starts in different places, especially when you're a big bunch of artists just trying to make computers do cool stuff. So
exactly.
We're always open. So
So I guess that's it. So thanks again to Rustfest for inviting us to this year's talk. And hopefully we'll see everyone in person in a future one.
Absolutely. All right, thanks a lot.
Thanks, guys. Bye.